Sometimes I like to just look up at the stars and think about how small we are in the universe. I know that sounds really cliched, but it's true. I get very poetic just thinking about the vastness beyond us, all the emptiness in outer space, and then the fullness of the planets and the black holes and everything else. And so tonight, I want to introduce you to my good friend, Jared Belcher of Digital Astronaut. We were talking recently, and I asked a question about how astronauts sleep in space. And it turned into this much larger discussion that I was not ready for about all of the different studies that NASA has done to learn more about the optimal ways for sleep in outer space, but also what that teaches us about the rest we need down here on Earth and work-life balance and all of these other things. And I knew we just had to do an episode about it. So I hope you enjoy this fascinating conversation that, yes, is about how astronauts sleep in space, but more broadly is about how what we are learning at the outer reaches of our atmosphere has incredible implications for how we think about life on Earth. I invite you to come along for the ride.
Jared Belcher, welcome to Sueño Labs. How are you today?
I'm excellent. How are you?
This is more of a collaboration. It's like you should be saying to me, welcome to Digital Astronaut.
Is this your debut on YouTube in this format?
It's my debut on your channel.
So okay, great. Well, I would say maybe this is embarrassing to admit. I think this is my debut on podcasting as a YouTuber. Okay. I've not been interviewed as a YouTuber before.
Oh, man. So we should probably go ahead and introduce you to people who are listening to this who are not familiar. So, and I could be wrong about this. Correct me if I'm wrong, but you are not an astronaut, correct?
Yeah, I wish that I were. I'm not an astronaut. Funny enough, I'm actually a pastor. I wear a lot of hats. But I'm not an astronaut. I wanted to be an astronaut growing up as a kid, and I think that's part of the impetus in starting the YouTube channel. So I'm a YouTuber. The crazy thing about being a YouTuber is you don't need qualifications for it. You can just be good at making videos and make videos for it. Incidentally, though, I really do love space exploration. And so for me, it was kind of a passion project. It's been a hobby, something I just love to share with other people. And I've played that role in people's lives that you probably have played as well, where like my friends and family, like I'm the person they're calling and FaceTiming about questions about space because I'm the guy reading the books. I'm the guy who's like obsessed with it. It's my passion project. And so eventually I decided, hey, I could probably make this into a YouTube video. I love making videos. I could probably do that. For me though, honestly, the moment came in 2015. And I did the thing when you wake up that like I know you're not supposed to do. Like you probably talk about it. Like I got on my phone first thing. Like I woke up, opened up Instagram, which is like, I know you shouldn't do. NASA had posted a picture of Pluto up close. Now, what's cool about that is I was a 90s kid growing up in the 90s. If you looked at a picture of Pluto, it was always like an artist's illustration of it. You probably remember.
Sure.
Because we could never see Pluto. Like even if you use like Hubble Space Telescope, it's so far away that it just looks like this tiny little pixelated dot. And I opened up Instagram, that random July morning, and there is a high resolution, detailed, full color photo of Pluto. And I had this realization of like space exploration just got democratized. Like all humans on Earth, suddenly like we had a picture of a planet no astronaut has seen. No one has seen. It didn't matter how much money you had, how famous you were. We were all in the same boat where we got to see this far off world together for the first time. And I had this idea, like I had this thought of like, we're digital astronauts. And that's where the name came from for the channel. And the idea is, there are so many probes and missions out there that are doing great science that people just don't know about. And so I'm really taking that stuff. It's being done by great men and women, planetary scientists, all of that, astronomers. And I'm bringing it onto social media so that people, everyday people, can see just the like wonder of our universe. And so that's where the name Digital Astronaut came from. I'm not an astronaut. I wish that I were.
Space is having a moment, right?
It is. Yeah, I started a channel at like exactly the right time.
Because you're right. We're basically the same age. The early 2000s or early 2010s, the story was NASA's underfunded. Going to the moon was this thing we did a really long time ago. Really, this idea of people being in space was this realm of science fiction. I think the prevailing global financial crisis narrative was not now, maybe not ever again. And now look at us. We've got private citizens going to space. We've got all of these different companies blasting rockets. We're sending people to the moon. We're having conversations about Mars. It's like it's back.
Gosh, it is so true. I love the space shuttle. I grew up like space shuttle era. Space shuttle is like it's my rocket vehicle, right? My nostalgic rocket vehicle. But you look at that whole era of the space shuttle, and it is just a chaotic mess of like, we don't know what to do. Like, we don't have enough money. Congress doesn't really want to fund us. The presidents barely want to fund us. The people don't really know what we do. It's dangerous. I think people call this right now, people will call this like the second space race, especially between like the US and China with the moon. I've heard like you said, space renaissance. For me, it kind of feels like we might actually still be in the very first space exploration phase. I don't think of like the moon 1960s missions as being step one, and now we're in step two. I really think we're really more in step one. That was maybe step one or 0.5, because it was really about developing the technology back then. And now it's finally like we're building the infrastructure that would be necessary to do proper space exploration. So it's interesting. It is still hanging on by a thread. I'll be honest. I don't want to paint too optimistic of a picture, but the things that are being accomplished are really remarkable. And it's a fun time to be a YouTuber talking about it.
Yeah, I mean, even just with how much of our daily lives are influenced by satellite communication, just in some kind of geosynchronous orbit. I hope I use that word correctly here.
Totally,
I'm trying to sound like I know about space to fit in. But yeah, I do think that you're right. Like seeing stuff on Instagram, it seems like every time there's like a super moon or a meteor shower, or you can see the northern lights, like everybody's talking about it. It's like there's kind of the bar has been raised with how much we're interested and how much we care about space exploration. And I think that public sway hopefully leads to some of those more serious inquiries of what could we actually discover, or what kinds of things could actually improve the way we're thinking about science on Earth, or even improving the way we're thinking about communications in the future. Or I'm sure all of these other far out implications of the kinds of things that could be possible.
Yeah, I mean, obviously, I'm an advocate for space exploration. What I think is really interesting is people think space exploration is really about the space part of it. It's especially now in this phase, it is so much more about life on Earth. That's kind of the piece that gets lost. When you think about the Apollo missions back in the 1960s, the missions to the moon, you and I are able to have this conversation, first of all, remotely, and then second of all, disseminate it to a large audience worldwide, only because of the Apollo missions and the technologies that were developed along the way, the engineers who were trained up through that project, the funding that those different science projects got at the time. We have our modern world today because of the space exploration that was done in especially the 60s and the 70s. That's not even to consider the actual breakthroughs that were done as a direct result, like the medical breakthroughs as a result of space exploration. So it's really much more about improving human lives here on Earth than it is even about actually exploring space. Because to be honest, we've barely stuck our foot out of the door in terms of leaving Earth. Almost everything we've done has been in what's called low Earth orbit. It's just the orbit that's just right next door to Earth. We're talking 200 miles away, very, very close physically. Difficult to get to, yes. Really an extreme environment, totally, but not very far when you consider the moon is 500,000 miles round trip, or Mars is 36 million miles away.
Sure.
I mean, things are far away in space. Space has a lot of space. We've really barely stuck our foot out the door. It's really much more right now about improving lives on Earth. I think that part gets missed by a lot of people. At least with manned spacecraft, it really is about life on Earth. Now the probes and stuff, that's about the science, and that stuff is super fun too. But it's also not as dangerous. It's not as expensive, and you get great pictures.
Yeah, that's true. Okay, so I think we need to go back to that for a second. So you mentioned that so many of these medical health discoveries that we almost take for granted have origins in space exploration. Why is that? Or how is that?
Well, microgravity changes everything, right? So microgravity is that effect that you see of everything floating in space. That people call it zero gravity effect. It's where there's weightlessness. And that totally changes the environment. The tests that you can do, the science experiments you can do, completely different than anything that you can do on Earth, where you have the force of gravity pressing up against a solid ground, where you experience the normal effects of gravity that we're familiar with, where things fall to the ground. So astronauts being weightless, you think about like the medical differences that they're that there are there because there isn't the effect of gravity. Two major ones are the loss of bone density and the loss of muscle mass. So these are things that we really didn't know about. Like before we went to space, we had no idea what the long-term health ramifications were of living in a microgravity environment. Even when the astronauts went to the moon in the late 60s, early 70s, they were only gone for a few days. So like Apollo 11 was gone for 8 days in total. And half of that time, they're on the surface of the moon. So they're experiencing gravity. It took us a while before we started building large space stations that people could live in for weeks and months at a time.
Sometimes accidentally when we leave them there.
Sometimes they get stuck there, right? So that's when we started learning, things are dramatically different in a weightless environment. Now, there are some downsides to that. We'll talk about that in a second. There are some positives, and the positives are you can do science experiments in space that you cannot do on Earth because just that microgravity difference alone makes a huge difference for your experimentation. So if we think about like the negatives of that, like physiologically, being in microgravity for weeks, months at a time, you do start losing muscle mass and bone mass. That's one of the immediate issues, dozens of times faster than like the most elderly person you will run into here on Earth. The reason for that is they're not using them. Like they literally, you don't need to use any muscle and any bone. You don't have to support your structure like you do here on Earth. Now you do have to move your muscles a little bit just to be able to navigate around a spaceship, but very minimally. You don't even have to if you just were buckled in all the time. That rate of bone loss, bone density loss, and muscle mass loss, it's so fast, it can be very dangerous for you to stay long-term. If you were to stay in space for a few years, you wouldn't ever be able to walk on Earth again.
Wow.
People who have stayed in space the longest have been like up there for a year. And when they return, they physically can't walk for a few hours, sometimes a few days. They have to be carried or put in a wheelchair or something like that. It is very dangerous to your body. Now, here's what's cool about that. Because from a medical perspective, you send an astronaut into space, you know everything about them before they even launch. You know every part of their body, their muscle mass, their bone density before they go. You know their genetic info. You know their diet. You know their exercise routine. You literally know everything about them. You send them into space, into, say, the International Space Station for 6 months at a time. You can track the changes that are happening to their body during that time. And when they return, you can do follow-up experiments as well. So what is great is scientists are able to devise experiments where they can do interventions while they're in space. So one of those, interventions might be increasing your vitamin D intake. So what happens? Okay, we know what your bone density loss is. What if we start introducing double or triple the amount of vitamin D into your diet? Do we see that progression slow or even stop? What if we modify your exercise regimen, or we modify which exercises you're doing, how much time you're spending on resistance versus on cardio, those kinds of things, working legs versus working spine. And scientists are able to come up with very well-structured experiments and test them in real time on these astronauts and see what happens. So you have an environment where medically these astronauts are deteriorating at a very fast rate, way faster than someone who has, let's say, osteoporosis here on Earth. And now you're able to test quickly. You can introduce interventions, get quick results, see how it works, and come back on Earth and implement those regimen changes into diet, medicine, exercise for actual patients. I mean, so many different kinds of experimentation, almost 3 decades on the International Space Station alone. So the medical community has had an incredible laboratory in space that they've been using to treat cancers, to treat different diseases. It's been really neat.
That's incredible. I feel like we don't get that in a Hollywood depiction.
No, it's slower and more boring, I suppose. Yeah.
Yeah. I mean, obviously there's like Star Trek or something, but even like an Interstellar kind of thing, like they never show that piece you mentioned where you come back and you can't even walk, you need a wheelchair. It just really changes my perception of what someone is risking, even just to become an astronaut. And it really levels up the respect that was already high. It's like,
yeah. And so I mentioned, we've been doing low Earth orbit for a few decades now. Skylab, Mir, Salyut. I mean, there are other space stations before the International Space Station, but they've all been in that low Earth orbit, very nearby, where the main difference is gravity. That's like the main difference there. The space station they're working on right now, and I say they as in NASA and JAXA and ESA and others on the Artemis project. That space station is called Lunar Gateway. It's very similar to International Space Station. It's just smaller, but here's a huge difference. It's in deep space. It is not nearby. So it is orbiting the moon in what's called a near rectilinear halo orbit, basically a big oval that always faces the Earth, so it's never out of sight of the Earth. But it's so far away from the Earth that it doesn't get the protection from solar radiation that you would get if you were at the International Space Station. Those astronauts are very well protected today, just by the Earth's magnetic field. This new Lunar Gateway space station will not have that protection. It's going to open up an entirely new set of medical tests that they're going to be able to do on these astronauts, which is one of the advantages of this particular orbit. Now, that does have some risks associated, right? Like,
yeah, I guess so.
People may not know NASA has a budget for how much an astronaut is allowed in their lifetime to get exposed to radiation. Astronauts might hit that budget real fast on the Lunar Gateway. We don't know yet. But the hope is that we're going to be able to use it to learn, how do we protect people from things like, for example, skin cancer better here on Earth from those experiments we can do on astronauts, admittedly, but this is what they sign up for. This is a part of it, right? But what we can learn from Lunar Gateway.
Yeah, I guess you need SPF 1000 or something.
You probably would, yeah.
I imagine that if it's like anything else, the Lunar Gateway is going to sell that sunscreen in the gift shop if you forgot it.
Yeah, you can't even exit without going through the Lunar Gateway.
Okay, so many things. One of the things we talk about a lot on Sueño Labs is sleep. So I imagine that if we're already testing muscle mass and bone density and skin cancer and all these other things, we are probably also, I imagine, doing some sort of experiments on this thing that we do every day of our lives, which is go to sleep. So before I even talk about that, I am going to admit that I actually don't know how you sleep in outer space, because every time I try to imagine it, it seems dangerous. Just like I'm imagining kind of floating, spiraling, somersaulting through the space station, crashing into stuff, crashing into windows. Like, do you have to like strap yourself to the bed? Like what?
That's exactly what you do.
Okay.
So what's kind of funny is you're asking questions that all the scientists were asking in the 1960s. We didn't know. How are you going? Can you even sleep in space? Alan Shepard, the first American astronaut, he tried to take a little nap when he first went up. John Glenn did the same thing following him. And I think John Glenn could, Alan Shepard couldn't. I mean, it's a difficult environment to sleep in because of the weightlessness. At least it's a major factor.
And you just had the most terrifying experience of your life.
You got the adrenaline pumping. I mean, you are, millimeter thin aluminum shell around you, protecting you from sudden death. Yeah, I mean, there's a lot of factors going on, but no, you absolutely strap yourself in. So like on the International Space Station, the way that it works there is you have a little sleeping pod that you get into. This is relatively light proof. It's not totally light proof, but it blocks most of it out. And you have like a little Velcro strap basically that wraps around a sleeping bag. So you climb into your sleeping bag. The sleeping bag is attached to a wall. Most of these sleeping bags actually have armholes that you stick your arms through, kind of like a sleeve. You stick your arms through, and you literally are just floating. You sort of just relax all your muscles, and you just stay there. What is really cool about that is my wife and I, we have a purple mattress. I'm sure you guys talk about mattresses quite a bit on your podcast. We have a mattress.
This episode is not officially sponsored by Purple, but
no. Yeah, this is anecdotal.
Yeah, there's a little product placement. I'm sorry. Go ahead. Tell us about your space mattress.
When you are looking for a mattress, a lot of times that people are looking for is like, I want to alleviate pressure points, right? Like that's what I'm looking for. That's like, and every mattress company will advertise this, like, no pressure points. It evenly distributes your weight. In space, you don't have to worry about that at all. Every single part of your body is evenly supported. It is the most perfect mattress. So astronauts have said, if you can sort of get past a lot of the other elements that actually do make it difficult to sleep, in terms of your sleeping position, it's the best sleep you've ever had. You don't have to worry about a crick in your neck. You don't have a pillow. Every part of you is just perfectly supported.
Wow. Yeah. It's like your whole environment is a pillow. It's like
exactly. Yeah. You're in a cloud. You're literally sleeping on a cloud. It's kind of funny though. Like the first American space station was called Skylab, and in 1973, the crew that went up there the first time, they were called Skylab 2, and they knew about the sleeping bag thing. At least they suspected it. It was the first time we were trying this, but they're like, yeah, that makes sense. We should strap in a sleeping bag. Totally makes sense. But they just brought regular pajamas. Like they brought, like just like you and I might wear, like sort of a flannel pants and maybe like a t-shirt or something. just like loose fitting stuff, because on Earth, loose fitting clothes are very comfortable to sleep in. It helps with body warmth, all those things. What they didn't think about is it's loose fitting. So even though they're in the sleeping bag, their shirt and their pants were just floating away and would make these huge air pockets around their bodies, and their bodies couldn't retain heat anymore. And they were freezing. So they couldn't sleep at all. That first crew had a really hard time sleeping. The second crew knew, okay, we got to bring tight fitting pajamas. And now that's what astronauts wear. They wear tight fitting, almost like a toddler might wear, like a foot.
Yeah. I was just going to say that. Like, I feel like that, we both have young kids. That's like what's in style now, is like the really tight fitting pajamas. So look at these toddlers being on trend.
His wardrobe is set for living on the station. Yeah.
Okay. So I have another question about this. So what about, on Earth, we've got a circadian rhythm that is in tune with sunrise and sunset. But when you are orbiting the Earth, you've got like 6 or 8 sunrises a day, maybe
even
more.
Oh yeah.
More? Okay.
You have, that's a great point. You have 16 sunsets and 16 sunrises per day if you're on the space station.
Do astronauts just try to ignore that and like stay on a 24-hour schedule because that's what they have on Earth? Or is there like especially if you're going to be up there for months, do you kind of adapt to that?
Yeah, well, I mean, the first thing is you have to pick a time zone, right? Like you can't just like be basing your life on the sun, because that's 16 times a day.
Yeah,
it doesn't work, right? So they picked GMT is the time, at least on the International Space Station. It's been the time on all the American spacecraft, which also works well because it's an international crew. So they just pick one time zone, GMT. Everyone sticks to it. In terms of the sunrise sunsets, light is a huge factor. When NASA first built the International Space Station, when they were designing it in the early 2000s, the thinking was, it's not going to have very many windows, and the sleeping area is not with the windows. We'll put a blackout kind of divider wall. They can wear masks. They'll be fine. That was kind of the thinking. It turns out that if you're an astronaut, I should also say that the space station was lit with like bright white fluorescent lights, like think hospital lighting. That's how the whole thing is lit on the inside.
That is the only lighting science knows how to do. I'm pretty sure. Every really laboratory, every hospital, every operating room.
But in this case, it's like you're forcing your lab, people to live in this environment night and day for months and months on end. So these scientists, they would go into their sleeping pods, and sure, they can get it dark in there, but they just came from this really bright white hospital lighting environment. You're not an iPhone. Like you can't just like float into darkness and instantly power down. And so it's really interesting. A lot of sleep studies have been done on the space station based on circadian rhythm, because one of the things we have learned is that your body is paying attention the whole day to the lighting around you. It's not just when you're going to sleep. So some of the issues with lighting in the astronauts would report, especially in those early years of the space station, that they would go into their sleeping pods for 8.5 hours and get 6 hours of sleep. And it wasn't because of noise. Sometimes it was, but oftentimes it wasn't because of noise. It was because they just couldn't shut their brains off. Couldn't figure out
too amped up.
Too amped up. Couldn't figure out why. And one of the reasons why, it turns out, is lighting throughout the whole day. So NASA has actually looked into this. They've upgraded the whole space station lighting twice. They did in 2016 and again in 2023 to replace it with LED lights that can dim but can also change color temperature. And so then what they did was they set the whole station to a schedule where automatically around 6 a.m. the station begins to brighten up. The lights begin to brighten up. It begins to go from warm to a cooler white light. And then for 15 hours in the day, it's this bright white, cool, in scientific hospital lighting. But then as it gets closer to the evening, 8 p.m. or so, that begins to dim. It begins to turn back to a warm. You think about like us here on Earth in the course of a regular day, even after sunset, it doesn't just go from like this pretty bright orange and red sunset to pitch black. There's an in-between even. There's a twilight, right? So it goes to like a purple, some dark blues. It gets dimmer and dimmer, dimmer, like a navy, all the way down till it's totally dark. So in 2023, they upgraded the sleeping pods to do that. So now it has a much more sophisticated, it has 7 different color diodes in the LED system where it's able to mimic an actual twilight environment, sunset, same with sunrise, kind of reverse it. And what they've seen is a huge amount of improvement in astronaut sleep. It turns out that the lighting throughout your whole day is giving your brain cues as to what you should be doing, whether you should be preparing for rest or preparing for work. It's not just about, is your bedroom dark enough? It's your whole day. And so that's a really fascinating kind of little study that NASA has done. There are some ways that it is uniquely dangerous to sleep in space. The thing that comes to my mind is if you're sleeping in weightlessness, we exhale carbon dioxide. If you're sleeping in weightlessness, that carbon dioxide, when it comes out of your body, it's also weightless. So what starts to happen is you're breathing out and you're sleeping and you start building a CO2 bubble around your head because it has nowhere to go. So astronauts early on started reporting really severe headaches in the morning, and they couldn't figure out why. But then when they would check things like oxygen readings and stuff, they began to piece things together. Oh, you're taking in a lot more CO2 while you're sleeping. Why is that? Oh, it's this bubble around your head. So now all the astronaut sleeping compartments tend to have a fan, like a personal fan that just blows at them, just to waft the CO2 away. And even if you don't have a fan, as long as you're somewhere near ventilation, that helps. But again, a really interesting, something we wouldn't be able to study on Earth, the effects of too much carbon dioxide. There are environments on Earth where that can be a very real threat. And the space station gave us an environment to be able to study something like that.
The lighting one is so fascinating to me because that's one that I can validate. And it's something that we talk about on this show all the time is, like dimming your lights before bed and not staring at phone screens. And just to hear that is something like truly science backed. We see it on the space station, I think is very affirming.
Yeah. You think about the fact that you and I we both have office jobs. We probably spend 80%, if not more of our time indoors. So our lighting tends to be controlled, especially at night, by artificial sources. Those are all things that are in your control. Being able to make sure that you don't have cool lights in your house, because you tend to use light at night. So they shouldn't even be cool. They should just be warm, amber kind of a color. There are, smart light bulbs are so cheap nowadays. Even being able to set that kind of stuff on a timer where you have an Alexa or something that, okay, it's getting close to sunset. We're going to start dimming some of these things. It's really easy to do now. And NASA has found that legitimately helps their astronauts sleep better at night.
Okay. So Jared, I have another question. You mentioned a few times NASA tracks sleep, or you've said that word. So when we think about sleep trackers on Earth, a lot of sleep trackers look at things that I imagine wouldn't apply the same way in space. So if you've got a sleep tracking app on your phone or a watch or a ring, a lot of times it's looking at things like movement. So how much did you toss and turn? Or it's picking up on things like auditory signals, like did you snore? Or it's looking at your heart rate, your breathing patterns. But I imagine that all of that is different in space. So is this just like your run-of-the-mill Apple Watch sleep tracking, or does NASA have its own proprietary thing that it's using? And if so, I want to know what it looks at to know how well someone is sleeping.
It's not as different as you might think. Actually, it's very similar. So all those things still apply. Your movement is still a relevant metric to look at in space because you can use accelerometers. It's not quite the same as something that you might either sit on your mattress, like a phone, or something you might wear on your wrist. Although, you could wear it on wrist. The thing is, in the space station, when they're doing sleep studies, they're wearing medical, like high grade medical sleep equipment. They're not just wearing like an Apple Watch or something, like a Whoop band or whatever. And no one likes sleeping with medical equipment. Like that's just not, you're never going to get a great night's sleep, right? It's just difficult to do. So it's not something they do regularly. When I say they track it on a normal basis, they're tracking it by self-reporting. Okay. They're not, unless they're doing a sleep study, which happens, unless they're doing that, they're just trying to get a good night's rest, and they know, just like you do, they know when they get a good night's rest and they know when they don't. If you're in a space capsule situation though, so let's say you're one of the SpaceX astronauts going up in Crew Dragon, they had Polaris Dawn was the recent mission where you're wearing a spacesuit and you're in a capsule that's connected, the umbilicals are connected to the spacecraft the entire time. I don't know what SpaceX does, but what they could do and what NASA does on all their missions is they can track your respiratory system, they can track your heart rate, and those are both useful metrics for sleeping. And NASA has done that on, Apollo, Gemini, Mercury. They'll do it on SLS. They did it on some shuttle flights, some parts of the shuttle flights. When you're in a capsule, that environment's a little bit different. On space station, they're using stuff like you and I might use. If they want to do sleep tracking, they're probably using an Apple Watch or something similar, Garmin, Whoop, something similar. It's really not that different, which is kind of encouraging. Here on Earth, those do have uses. Like they have really relevant data to you. But again, what NASA has found is there's so much more that's related to the pre-sleep time as opposed to the actual sleeping time that actually affects it a lot. So it was really interesting to me, and we can get into talking about crew schedule here in a minute. But when you look at their crew schedule, they have an enormous amount of time allocated to what they call pre-sleep. It's 2 hours a day. That is pre-sleep time to prepare their bodies and their brains to go into an actual restful, deep sleep.
So it's astronaut bedtime, right? That's what we do. It's like, you have a snack, you read a story,
right.
You have to get a glass of water. Like that takes 2 hours.
Do you think they read Good Night Moon? Like they're like sitting in the cupola, like looking at the moon.
Oh my goodness.
I hope so.
One thing that stood out to me that I think I don't always consider is you mentioned how if someone's on the space station for a while, there's going to be nights where they're tracking, but then there's other nights where the way you described it, you didn't say this, but it sounds like they get a night off. Like, hey, we're not going to hook you up to all of the apparatus. Like, just go to sleep, man. Like, have a good night and we'll check in at 6 a.m. or whatever it is. And, we'll ask you how things are going over breakfast. So one of the things we were talking about even before we recorded this episode is like that's not always been the case.
The astronauts, they used to have a really rigorous schedule, and that has changed. And it's been really interesting to watch that change unfold. Do you mind though if I kind of go into a little bit of the history of what was going on in the 1970s though? Because I think it helps for us to have some context of where NASA was at when they first started sending astronauts into space stations. They were, if you think about the 1970s, we had just landed on the moon. That was like the big goal. And that was the reason NASA was created, was to land people on the moon, to compete with the Soviet Union in this very global display. And yay, we did it. We sent these missions to the moon. This is why I say we're kind of still in the first phase, I think, of space exploration, because as far as the public and Congress and even the president, Richard Nixon at the time, as far as they were all concerned by the early 1970s, there really wasn't a reason for NASA to continue. Like, there was a big movement to shut down NASA. It did the thing it set out to do. We're in an economic crisis. The Vietnam War is happening right now. We need to divert funds from the space program to somewhere else. And it was seen as a really temporary problem that was solved with a temporary solution. But you're NASA. Think, if you're NASA, you want to continue space exploration. You have a lot more dreams you want to do. NASA had drawn up plans to go to Venus, to go to Mars, to build space stations in orbit and on the moon. They had a lot of ambitions. No one wants to fund it. And you know how like everyone talks about how Apollo 11, the first one, everyone in the whole world, they tuned in, they all watched it live. You get to Apollo 17, no one is watching. CBS and NBC both have their stations have callers calling in saying, why is the moon landing on? Like, I want to be watching my TV show right now, complaining that they're watching a moon landing, right? NASA's in this situation. They want to do something. And the best that they can get approved is this program called Skylab, which is basically taking parts that were left over from the moon program and just reconfiguring them into a space station. Literally, Skylab, the station that they're in, it's a fuel tank. They're just in an upper stage of the Saturn V that's gotten repurposed. There are a lot of problems. It does not go super smoothly. On the launch, it barely makes it to orbit. Part of the sun shield gets ripped off. Part of the solar panels get ripped off. They're not even sure if it's working properly because it launched uncrewed. So it's already a mess. So astronauts, and this is still true today, if you're a NASA astronaut, you have a really well-planned schedule. NASA plans your schedule for you. That was true then as well. And so if you're NASA and you're looking at all of these problems and you've got to convince the public this is worth it, the public knows this is expensive. Like that's part of the problem, right? It costs a lot of money to go to space. Today, if you look at just the International Space Station, the cost of building the space station, assembling it, keeping it running, all the people on Earth who are in charge of keeping it running, the space shuttle program that built it, paying your astronauts, you add all that money up for the last 30 years, it's somewhere around $150 billion. It's a lot of money. If you divide that by the number of minutes astronauts have been on the space station, it comes out to $951 per minute. that an astronaut is up there, right? That's about $1 million a day. It's a lot of money.
Yeah.
And it's taxpayer money. So 1973, you have the very first space station, the American space station. You know, you're thinking, these aren't the exact dollars, these are today's dollars, but $951 per minute. I would do this too. We're going to squeeze every ounce of productivity that we can out of these precious minutes. So it's going to be the most productive space station people have ever seen. That was the mentality they had. And it was also coming out of, the first astronauts were military. So they're still in that military mindset. This is how this is how these people operate, even though NASA's goals are shifting to scientific. All these things are happening at once. And those crews, man, they burn out. Within the first couple of weeks of their missions, it's funny, they did 3 missions. Really, all 3 sort of follow the same patterns. Those first few weeks, the astronauts are making mistakes left and right. They are way behind schedule. You know, the first crew at one point, like 2 weeks in, NASA phones and they're like, you guys are 50% behind schedule. You've missed 50% of the work you should have done by now. So NASA's frustrated. The astronauts are frustrated. This thing is about the size of a basketball court. And you have parts of your tasks, if you're the astronaut, that are on both sides that you've got to do. So like, they're not just sitting at like a computer, like typing in 0G. Like they're like bouncing back and forth. Like they're legit sweating, right?
So NASA is the worst boss ever at this point.
They're the worst boss ever.
They want you to work around the clock. It's like this impossible expectation. They're calling you in the middle of the night to say, why is your work not done?
It is. No. Okay. That is legit. I'm not even kidding. You are exactly right. So what they're tracking everything. And like I said, they're not always tracking the vitals during sleep. But what they can see is they can see gyroscope movement on the space station. The gyroscopes are the parts that keep the space station facing the right way in space. And so in the middle of the night, you'd have someone in mission control and they would see the gyroscopes spin up and start making sure the space station was in the right orientation, which meant something was pushing against the space station from the inside, aka an astronaut was going to the bathroom. They could see that on the chart and they would phone the astronauts in the middle of the night. Hey, we see someone's up there awake. Can you go and do this thing for us real quick?
Wow.
So, I mean, and like you read the journals of these astronauts, this was happening constantly. They would stagger their meals. So there'd be one person eating and 2 people working so that there was no socializing during a meal. They were supposed to have a day off once a week. It didn't happen. Even holidays tended to get missed. NASA would say, hey, sorry, boys, we got some stuff we need you to catch up on or to do. And the other thing about being in space is if you're working in space, small mistakes can become big problems real fast. If you turn the wrong valve, flip the wrong switch, you could kill everyone on board. That never happened, thankfully. But, it's certainly there was a real safety risk involved. After a few weeks, it caused a lot of, as you might imagine, a lot of problems. But it also caused the astronauts to fall way behind on productivity. I mean, this is an amazing experiment on like American workaholism culture of like, if you hustle at 100% from the minute you wake up to the minute you go to bed, first, you're not getting a good night's sleep. That's just not going to happen. But you can only do that for so long. At some point, your productivity it's counterintuitive. You've actually depleted your ability to get work done. And what NASA saw with all 3 missions was even if the quantity started going up, the quality never did. So in each of the 3 missions, this did not happen simultaneously, but NASA started making changes that at the time was sort of a let's just try it kind of a mentality of building in rest and some thoughtfulness into crew comfort to see if that would affect productivity. It would be doing things like, first of all, having the crew eat 1 meal together per day. So making that change where they're at least doing dinner once per day all together for like a good solid 20 or 30 minutes that they have. It's guaranteeing a 1 day a week break. Unless there's an emergency, you get 1 true day a week off where you can do whatever you want. It was building in some time before bed where they didn't have to, if you look at that original schedule, they were going from 9:59, they were working, and 10 p.m., they were supposed to be asleep. No one can do that. And so building in some like cool down time, giving them flexibility on those early days on the space station. I mentioned their exercise was planned out. It wasn't just in their schedule, hey, go do an exercise. It was literally like, we need you to do this exact exercise, this exact number of reps with this exact amount of resistance. And then we need you to report exactly how that went. It was this whole, thing where it wasn't just about the science. It was also just about the control to make sure that astronauts were doing what they were supposed to do. they said, we're going to do some medical tests with exercises, but otherwise do whatever you want. We'll give you 2 hours a day. Do whatever you want. It's up to you. They started making these changes, and guess what happened? Productivity exploded. All 3 missions, again, this didn't happen simultaneously, but it kind of played out with each one of all 3 of these Skylab missions. All 3 missions completed their total mission, whether it's 84 days or 60 some days at the end, ahead of what they were supposed to get done. They got more tasks done than they were originally supposed to. The first crew, Skylab 2, got like 150% of their workload completed. Skylab 4, which was an all rookie crew, was like this whole thing. They had no one had ever been to space on this crew. Did not go great, as you might imagine at the beginning. By the end, they were begging NASA for more tasks to do because they were bored. They had gotten it all done and they wanted more work to do. NASA learned a lot from those early Skylab missions, that there is such a relationship between work and rest. You cannot just have work and get the productivity that you hope for. Humans aren't wired. We're not machines. We're not wired like that. And so they found when you build in things like protected sleep, protected days off, protected holidays, protected mealtime, crew flexibility, when you build those things in, your productivity skyrockets, which is something that applies to every single person on Earth. I mean, I do this all the time. I don't know about you. I do this all the time. I pack my schedule full and I run like I'm a machine, like I'm a robot, but we're not wired that way. When you think about astronauts, whether they're going to be on the surface of Mars or on the space station today, they are following a strict schedule because they're paid astronauts. They're there for a reason. But that time now, when you look at their schedule on ISS, they have 2 hours of a bedtime, just like we talked about, to wake up in the morning. That starts at 8 p.m. to 10 p.m. They go to bed at 10. They have 2 hours when they wake up, actually. They call it it's on their schedule as post-sleep before they ever get into any work. And the idea there that like NASA had early on with this International Space Station was this idea of sleep inertia. I don't know if you're familiar with that term, but like I hadn't heard of it until I came across it with some of their research, where you're still, your brain isn't fully functioning. And that has big consequences in space. You need your brain to be fully functioning when you are doing space things. So they give their astronauts every day. You get 2 hours after you wake up, drink your pouch of coffee, have your orange juice, look outside, take some photographs, write an email to your family, do a FaceTime call, just like fun things. And again, I think if we're going to go to Mars or we're going to go somewhere far out, we're going to have to implement those best practices for just how to be a human and how to work well and how to rest well. And it turns out those lessons apply to everybody here on Earth. Treating your rest time like it's sacred has been a lesson that NASA has learned along the way. And something I've noticed I'm not good at, I think a lot of us struggle with, where even when you have days off, you don't treat them like days off. Like you fill it with busyness and with work. And one of the things that NASA learned from Skylab is a day off needs to mean a true day off. I mentioned at the beginning that I'm a pastor. So I think in terms of spiritual sense too, this concept of Sabbath. So, in the book of Genesis, in Genesis chapter 1, God creates everything and then he rests. And then in chapter 2, he explains to Adam and Eve, hey, this is a part of your rhythm. Rest is supposed to be a part of your life. We see that echoed again through Exodus and then even Jesus in the New Testament, where human bodies really are made to have a built-in weekly protected time of rest. And I say protected because it's so easy to fill it. Like we have kids. It's just easy. It's just easy to like do all the sports stuff. It's easy to like get involved with too many extracurriculars. It's easy to squeeze some extra work, some side hustles in on those off days. And suddenly your Sabbath, your day of rest, whatever you call it, is gone. And you're hitting the work week just as tired as you were before. This is something that NASA's gotten really good with the astronauts on the space station, on the International Space Station, of helping them develop hobbies that actually carry over onto the ISS. You got to have something to do, right? Like I mentioned, Skylab 4 crew was bored at the end because it wasn't built for recreation. You got to have some fun. You got to have hobbies. So the astronauts today, that is going to vary. Some write, some paint, A lot of them do photography because, I mean, you're in space, you're floating above Earth, right?
Yeah.
A lot of them will do, a lot of them come from a teaching background or just love teaching. And so they'll use that time to FaceTime kids on Earth or family members or friends, and even for fun, talk about what they're doing, talk about what they're seeing, not in a work capacity, but just out of a joy of teaching. Reading, of course. I mean, it's things we would do. It's watching Netflix, playing video games. Those are all a part of their rest rhythm. But it's protected time. It's, this is not work time. Now they're actually up to about a day and a half of rest per work week is where NASA is at. So again, this is an organization, they are very attuned to productivity. They're very attuned to their money incentives to keep things as optimal as possible. And they control 100% of the environment that their employees are in. And they have found we got to give them a day and a half that we guarantee, unless there's an emergency, we are not going to bother you. So it's kind of neat. NASA has learned a lot about that relationship between work and rest.
So if you are a CEO or owner of a company listening to this and you have not gone to the 4-day work week and summer Fridays, NASA commands it. I think we can. So that is actually fascinating to me, because I think that that's something that we often say, or we kind of intuit, or we think, we maybe experience it in small ways. Like we've probably all had those experiences where we're super tired, we're out too late, and for some reason we're driving a car and you like blow past your own driveway because you're not paying attention, or like we just notice these little mistakes that in retrospect we think, okay, wow, like that could have been really serious. I'm not paying attention while I'm driving because I'm so tired, and we kind of write it off. But to your point, like seeing this play out in such a controlled environment really supports the idea that this is not a personal problem. This is really a human being condition. We need to rest. We cannot function on this 24/7 lights on all the time environment. I think that's incredible that we've actually seen that play out.
Yeah, and what I also think is really interesting about that story with Skylab specifically is I talked about the original incentive for that push was money, right? It was, this is expensive. We don't know if we're going to have enough money. That's no different than the reason that probably most of us are hustling so hard. It's the same impetus, right? It's that drive for, even if it just feels like I got to do this to survive, you can only do that for so long. And it turns out, are you familiar with Ali Abdaal? I read a great book he wrote called Feel Good Productivity recently. And in it, he cited a story I hadn't heard of this 52-minute to 17-minute work rest rule that apparently scientists have found is like the optimal amount of work, where you work for 52 minutes and you rest for 17. And it's like the optimal ratio of work and rest. I just think that's fascinating and is so not how I work. I don't do that. I sit down at my desk and I power through it. I go to my meetings, I take my notes, I send my emails and my Slacks. I'm responding promptly. I mean, I'm hustling until I get home and my brain is still going. And a lot of times I'm still even working a little bit at home too. We're not, at least, I can speak for myself. I'm not good at building in that rest. And NASA has found, hey, no, like if you want to be productive, you got to rest well.
I do a lot of writing. And so I usually don't go 57 minutes, but it's usually more like 20 or 30 for me, where sometimes I'll set a timer of like, I'm just going to knock this out. But then once I hit 20 or 30, I do need to take a break. So I found that is helpful for me to not try to power through a 3-hour writing session, but to break it up into those little chunks. And then I'll usually finish faster, just like your astronaut story, because there's those breaks in there. There's so many applications. If you're thinking about employee productivity, you're probably not paying your employees $1 million a day.
Yeah.
That's approximately what I make doing podcasting, but not quite.
Yeah, and to be clear, the astronauts aren't making that money. I think they wish they were making that money. Yeah.
I feel like they should, based on what we've been talking about. Like, you're getting phone calls because you went to the bathroom in the middle of the night. People are tracking you 24/7. At any given moment, you could be exposed to deadly solar radiation. Like, I feel like you should be making that kind of money. That's pretty crazy. But yeah, so it's like, if you're thinking about, okay, I have employees, I want them to be as productive as possible, I'm paying them this amount of money, just realizing that in order to get that productivity, building in rest, and even just use the ratio you just shared. Like the rest isn't just, okay, you get the weekends off. Rest is, you can take breaks. You can take a long lunch. You know, if you have a personal phone call that you need to go take, like you can do that, because I recognize that when you're taking those breaks, you are actually going to be more productive, because that rest is built in, and then you're going to sleep better at night, and then you're going to be better the next day, and all of these things.
Yeah, it absolutely has. I mean, I think all business leaders, all of us could learn from the same lesson that NASA has learned. You will see productivity go up when you value your employees' comfort and their time. It's counterintuitive, but it actually is self-serving. It serves you well.
So just as we're coming to a close here, I'm curious if you have an answer to this. As we look ahead to the Artemis mission, and hopefully this doesn't, hopefully this ages well. If you listen to this a year from now, nothing's been canceled or gone wrong with that. But what do you think are going to be some of the coolest takeaways of going back to the moon?
Yeah, so the moon is really interesting because it is a space environment, but it has gravity. That's one huge change. It has the gravity. It's a third of Earth's gravity, so it's not quite the same. But it gives you the ability to explore another world that is relatively close, and potentially to be able to set up an infrastructure for deep space exploration. Everyone really talks about the moon as being a stepping stone. There are scientists who are excited by itself for what we're going to learn about the origin of the Earth-Moon system, about what even the moon sort of is an archaeological point of interest as well, because it does have, like, if you look at the geology of the moon, it's going to be able to tell us some of what Earth has experienced during its lifetime. That's all really interesting, but everyone really talks about it in terms of a stepping stone. That's really how it's being viewed, is what can we learn there that we are not able to learn right now? Because people want to go to Mars. Going to Mars is a lot harder than people think it is.
I already think it's hard. So
yeah, I think there's this idea though that it's like you build a rocket and you just go there. It's gonna be unbelievably hard. And I do think, like, people like Elon Musk are so optimistic. It can paint this picture that it's totally feasible. It is not. Like, today we cannot do it. If we want to go into deep space and send people into deep space, and I hope that we do, you have to have a proving ground, and that's what the moon is being used as. I mentioned all the things we learned just from low Earth orbit about not only living here on Earth, but living in space. That's the hope, is that we learn the same kind of things there. How do we deal with solar radiation? So, like, one idea is putting crew compartments within water tanks. If you surround it with water tanks, water is very good at absorbing particle radiation and ray radiation, actually. And so the idea is, what if we try some of those techniques and see if an astronaut is wearing a device that can measure what they're being exposed to? Do we see an effect? That would be useful to know going to Mars, because, again, Mars is just getting blasted. It doesn't have a very strong magnetic field. It's getting blasted by the sun's rays all the time. Things like rocket fuel. Rocket fuel is very expensive. It's very expensive to get into orbit, I should say. If you want to go to Mars, the amount of rocket fuel you need, if you just wanted to, like, launch a rocket and go to Mars, is, like, unfathomable. Like, we're talking, like, you would need like 10 to 20, I don't even know, Saturn V's, like, pushed together. Okay. Because it's not just going there. It's like, you want to slow down. You want to get it. You want to land on Mars. That takes fuel. You want to come back, presumably. I think most people want to come back to Earth. It takes a lot of rocket fuel. If you want to do that, a really economic way to do that is to make your own rocket fuel somewhere along the journey. So the thinking is the moon might have some ice. We don't know for sure, but it might have water ice in the polar caps, particularly the South Pole. I say we don't know for sure. We know there's water ice there. We don't know how to get to it. We don't know if it's in dense quantities, if it's finite and dust-like. We don't know how deep it is. There's a lot we don't know. We're going to have to go to the moon to figure that out. If you can find water ice, you can convert that to rocket fuel and make a refuel station with hydrogen and oxygen, and to be able to go to Mars or somewhere further by refueling at the moon. So everyone kind of sees the moon as a stepping stone. There's some prospects of mining the moon. That's certainly a possibility. The question is there anything valuable enough on the moon's surface that it would be worth the money to not only go there, but to return it? That's not easy. That's not cheap. Don't know. I'm kind of skeptical about that being worth it, but it is a proving ground. So we really are still in that step one of space exploration. We're going to learn a lot about what it's like to sleep on a world like that too. The gravity is very similar on the moon to Mars. So
Okay.
it gives us a great analog when we're looking at the design for lunar landers. So SpaceX and Blue Origin right now are the two companies contracted for Artemis's lunar landers. They haven't shown what sleeping will look like on there because there's gravity, and beds are not really something you want taking up precious space on a lander like that.
Sure.
Apollo had hammocks on the moon. That's kind of a neat trivia question. Most people don't realize astronauts had hammocks. They weren't really used. They didn't really work very well. So my suspicion is I don't think the astronauts are going to get great night's sleep on the moon. We got to figure that out. Because a Mars mission you're looking at 3 years round trip, and in a capsule, right? Away from everyone you know and love, moments away from death at any given time. It's a stressful environment. We got to get some good sleep. So
we've seen The Martian. We know what can happen.
Exactly.
Yeah.
So even just like the practical stuff that we can't test for now, that's what we're going to use the moon for. And it's one of the reasons I'm really excited. And you mentioned timelines. I think it's further out than you will hear about on the news or that you read about online. This stuff is really hard, and it really is. It is a little bit underfunded, to be honest. Most of the delays are simply because of money issues. So, yeah, it's going to be exciting, but it's going to be a while.
Yeah. So even if you are not likely to become an astronaut, we can still live like astronauts by protecting our rest, protecting that Sabbath, and really just taking that time to make the rest of our work time more productive. I think a good summary here.
Yeah, that's exactly right.
Jared, where can listeners go to learn more about you and more about everything incredible that is happening in outer space?
Well, I mean, I would always say I'm happy if you want to give my videos a watch on YouTube. The channel is called Digital Astronaut. I tend to cover things that are sort of both sides of it, things that you'll find in space, like planets and stars. Space is very big. There's a whole lot to talk about. But I also talk about the exploration side too, which is, of course, a lot of our discussion driven today. There are some great YouTubers, though. I'm certainly not the only one in the space. If you have an interest in what it's like to go to space or just space history, Scott Manley, amazing resource on YouTube to watch. He's a Scottishman. He covers a lot of space flight history. And then if you're just interested in rocketry at all, Tim Dodd, the Everyday Astronaut, it's hard to beat Tim Dodd. So there are a lot of, like you mentioned, we're sort of in a golden age of space exploration. We're also in a golden age of space content. There's never been so much content. So I'd love for you to give my channel a listen or a watch. But there's a lot out there.
Jared, thank you so much. We've waited too long to do this. This has been super fun. And I'm just going to go ahead and call this part 1, because there's going to be a part 2 when we talk about how successful the lunar gas station motel is going when that inevitably happens. So I'm going to be optimistic. Why not? I have nothing to lose about being optimistic there.
Let's do it.
All right, Jared, thank you so much. It's been so fun.
Thanks, Jimmy. Appreciate it.